Welcome to Unite Now, where we bring unity to you, wherever you are.
Hello, welcome to Game Foundation Pre-Built Common Systems for Your Game, a Unite Now 2020 talk. I'm Erika Dains. I joined Unity a little over 4 years ago, and I'm currently one of the developers on the Game Foundation team.
And I'm Joslin. I joined Unity a little over a year ago, and I'm also on the Game Foundation team.
We're really excited to share with you all today what we've been working on. We'll start by going through some of the common problems developers such as yourselves have reported experiencing. Then, we'll dive into a high-level overview of Game Foundation and the ways in which we believe it can help to solve these problems. Next, Rich will take us through a demo using a real game project from a Unity customer to show you how to use Game Foundation. Finally, we'll finish up by talking a bit about the future roadmap of Game Foundation. First, let's talk about the problems we're trying to solve. We've heard from many Unity developers repeatedly that they consistently have to reinvent the wheel on common game systems. Things like inventory, in-game currency, stats, store, reward, all common systems to have in your game, but that frequently need to be built new each time. We understand that as developers, what you really want to be spending your time on is building a good game with unique gameplay that truly lets your game stand out. But these common systems are like plumbing that have to be built first to give your game a solid base on which to build your gameplay. Also, in this competitive market today, developers often have to work through the development lifecycle of your project quickly and find it hard, perhaps even impossible, to spend time and effort making these common systems reusable and flexible. As a result, when you move from one project to another, you may have to start all over again, creating a lot of one-off implementations of these common building blocks. Even if you try to build these systems in-house, it can be difficult to maintain and keep it updated over time, or to design it in a way that is flexible enough to work with more than just one specific type of game. We also heard that many developers have tried using third-party asset plugins, but then struggle to get these heterogeneous systems to work well together due to a lack of a common contract, and find that you end up spending too much time trying to force these systems to work together. Last but not least, more and more games today want to provide dynamic updates to their game content that keep the game fresh and to continuously optimize the game's performance through live ops strategies. To do this, these common game systems often need to be connected with a backend, and developers have told us how much complexity there is to building the full stack solutions necessary to span across both the client, the Unity editor environment, and a server backend. You may feel like we just described the story of your life as a developer, but now we hope to provide a solution to these problems to make your life a little bit easier. In a nutshell, we are designing Game Foundation to provide pre-built common game systems that are flexible and extensible. Our pre-built modules are tested, standardized, and take into account industry best practices. Additionally, they are written to be flexible and extensible, allowing them to fit into many different game genres and be customizable for your project needs. Let's dive a little deeper into these modules and see how Game Foundation can be helpful to your Unity game development. Think about when you're building a game today. You likely won't try to write your own versions of Unity's rendering or physics systems, instead using what Unity provides. The Unity engine has taken care of that lower level of development for you. Similarly, Game Foundation would like to take care of the middle layer of development for you. We know you're constantly seeking innovation and creating unique gameplay when building out your complete game. However, developers still have a lot of common game systems to put into their game. Regardless of the genre, your game probably needs some type of game economy resources, like items or in-game currencies that can be stored in a player's inventory or wallet. And these resources often have to come from somewhere, for example through in-game store purchases or from player rewards. And then, as you build out your gameplay, very often you need to be able to attach various stats to many of these in-game concepts to provide extra details about them. Additionally, should you want all this game content to be updatable or A/B testable, you also need to be able to connect them with a backend. Then, at runtime, as the player goes through your gameplay, you probably want to store their game state somewhere as well. maybe not just on a local device, but also on the cloud. So player data persistence is another challenge developers have to go through. Things like supporting offline gameplay while the client has no internet, or server authoritative mode, makes this task even more complex. Now, with all of that, you probably realize that between your truly unique game content and the low-level Unity engine layer, there's a lot of common systems that you have to deal with. With Game Foundation, however, our vision is to make these common game systems available to save you time, so you can make better games rather than reinventing the wheel for each game you make. Today, we have these systems available in Game Foundation: inventory and in-game currency for defining your game economy resources, stat system for tracking dynamic attributes in gameplay, a flexible transaction system that does resource transformation, allowing use cases like virtual purchasing, IAP purchasing, and a crafting mechanic by automatically deducting the costs associated with the transaction and adding the rewards to a player's inventory or wallet, and a store system for building an in-game store. In future, you can imagine having many more common systems being added to this list. We also provide a deep set of capabilities for each of these systems. First, all the definitions are LiveOps enabled, meaning you can update the settings remotely. Imagine adding a new resource to your game and making that available in the in-game store by simply pushing an update from the cloud to all clients. Also, we provide data persistence for both local and cloud storage. Analytics is also built in. You may have tried to implement game event instrumentations in the past. Not only is this tedious and time-consuming, it's also error-prone, having to make sure you update your gameplay logic and analytics at the same time. Now we have auto analytics baked into the system we provide, so you no longer need to spend time on that. A/B testing is another important tool for determining which version of your game is best, and another one that is time-consuming to implement. Game Foundation will help take care of that too, with built-in functionality for working with A/B testing. Finally, server-side logic can be very important for keeping your game secure. Developers frequently want to ensure that some key logic, like a purchase of premium content for example, is processed remotely, avoiding the potential for manipulation on the client. However, implementing the server-side logic can be complex. Game Foundation addresses this problem by providing a simple interface for using a server-side data layer for some processing. And in the future, we also plan to support a full server authoritative mode for these game systems we provide. Now that you know more about the problems Game Foundation is trying to solve and the systems that we're providing, let's take a closer look at the architecture of those systems. Sitting on top of the Unity engine and integrating with some key Unity services, Game Foundation is a package made up of three main parts. First, each game system has a C# API that developers can utilize to access these systems at runtime. Additionally, we provide a set of prefabs that interact with that API, providing a more drag-and-drop experience for developers who want to get up and running more quickly. These prefabs are designed to be easily customizable to fit into the look and feel of your own game. We also provide an editor workflow for defining the elements of these game systems that make up your game, streamlining your development process. This also means that non-programmers on your team, such as game designers, can also leverage the editor UI to configure and balance certain aspects of your game systems. Now, let's take a closer look at the Game Foundation API. We have created a common data model for defining key game economy concepts, such as inventory, currency, and stats. Our various systems are built on top of this data model, allowing for easy communication between the systems. There's also a data layer that abstracts away the data storage, allowing us to create several different adapters to suit the particular needs of your game. This allows you to choose between storing data in the cloud, in persistent local storage, or temporarily in memory. Similarly, we provide adapters that let you easily connect Game Foundation to analytics and LiveOps solutions. Next, let's take a look at some of the prefabs we provide. Here, we're showing our default store prefab design on the left and a few examples of ways it can be customized to fit your game on the right. The default design is based on common conventions in store UI layout and comes with options for both portrait and landscape style games. We try to be as unopinionated as possible on the visual style of the prefab, while designing them to be easy to customize, giving you lots of room to adjust it to quickly match the look and feel of your game. Here, you'll see a few examples of our editor workflow. We want to provide you with an optimal workflow to define and manage all the necessary configurations for our common game systems. The windows currently shown are for defining inventory items and transactions. And if you need to import data from outside into the Unity environment, for example, from a Google Sheet, we also provide an editor data API that allows you to programmatically create and update these data definitions. You'll see more about the editor workflow during Rich's demo. So far, we've talked about some of the problems game developers face when building common systems for their games, the ways in which we believe Game Foundation can help address those problems, and taken a closer look at the architecture of our Game Foundation systems. Now, Rich will walk us through a demo of integrating Game Foundation into a real game. Rich?
Thanks, Erika. For the demo, we'll be using a real game project from the studio Duello Games. Duello Games is a 5-person team founded in 2010 and based in Istanbul. Today we'll be showing another game they recently launched called Flipper Dunk. It's a single-tap casual game combining the well-known mechanics of pinball and basketball. It's a challenging game with fun power-ups, and it's suitable for all ages. Since its launch, Flipper Dunk has become a very popular game, reaching number 2 in the games category and number 4 overall in the US App Store during Christmas 2019. As the team tries to also build a sustainable business, one thing they want to have is an overhaul of game economy and introduce a full-fledged in-game store. In the following demo, we'll walk through how Game Foundation can help the Duello Games team accomplish this. The Game Foundation package. Open up the package manager from the window menu. Game Foundation is a preview package, so you need to enable preview packages. And you can search for Game Foundation to find it quickly. Then just hit the install button. Downloading and installing will take a few seconds, and then your project will re-import and recompile, and then it's ready to start using. To start working with Game Foundation, you can find it in the window menu. There's a currency window. This lets you set up soft and hard currencies, in-game currencies, premium, real money bought currencies. Then there's a inventory window that lets you set up inventory items such as power-ups, etc. Then there's a transactions window. This lets you set up in-app purchases and virtual purchases for your store. And then we have the store, which lets you refine how your transactions show up in your game. To create a currency in the currency window, hit that plus button, enter a display name and a key string, and then you get to choose which type of currency it is, soft currency or hard currency. A soft currency is an in-game currency, but a hard currency is bought with real money through an in-app purchase, or IAP. Then you can add any number of image assets that you want to visualize this currency in the game. Usually you'll have an icon that shows up in the wallet, and then maybe you want a different icon that shows the currency differently in a purchase button, so you can add that too. Let's go over to the inventory window and start creating some inventory items. It starts out just like creating a currency. You'll choose your display name and key. One difference in creating inventory items is that you can categorize them. You can add any number of categories you want, create them on the fly. They are useful for helping you find inventory item definitions or finding items in the inventory based on their categories. It works just like tags, basically. So for Flipper Dunk, we've got a wide variety of balls that you can dunk with, from basketball and football to watermelon. So we'll create all those definitions here, and then in the game, we can create instances of these definitions in the inventory. At runtime, you can have, say, 4 basketballs in your inventory, and all of those basketballs will point back to this basketball definition. Say if you want to get an image asset for a basketball, you would look back to the definition. So in Flipper Dunk, we want there to be a way for the player to buy more basketballs. So we have a transaction system and a transaction window for creating transactions. It's much like creating the other items we've created so far. You'll choose a currency and you'll choose a reward. We'll say spend 1 gem, get 1 basketball. You can add some icons to represent this transaction. Say in a store system, we'll have a store icon for this transaction. While we're creating more transactions for all the different kinds of balls in the game in the background, I'll just talk more about the transaction system as we go. And the first thing I'll touch on is the categories here. It's going to be important later because the categories are used in our store prefabs. The store prefabs are going to make it a lot easier for you to quickly put together a UI for a store in your game. And what you'll be able to do is just drop the store prefab in, choose a transaction category, and then that store grid view will just automatically display all those transactions and icons that you just set up. So we'll get to that in a bit. We're going to talk about 2 different kinds of transactions. There's the virtual transactions and the IAP transactions. Right now we're setting up virtual transactions, which means we're going to use virtual currencies as the cost, and then you can get back either inventory items or currencies in your wallet. IAP purchases will be a little bit different because you won't be able to spend virtual currencies as the cost. You'll have to spend real money, and we'll talk about that system more in a little bit. And this transaction system is a little bit generic. These transactions don't work by themselves. You need some other system to present the transactions and to start executing the transactions. In this case, our store system is going to present all these transactions. And we'll show you how to set up the store system and to set up those prefabs in a little bit too. But my point now is that these transactions could be used for other things too. For instance, let's say you have a very basic crafting system, recipe system, where you can spend a couple of inventory items to get a different inventory item. That's another way of using this transaction system in your game, and that capability is there now. Now that we've got all our virtual transactions set up, let's set up some IAP transactions. These are going to be real money purchases, which will be set up to purchase in-game currency with real money. The major difference between setting up a virtual transaction and setting up an IAP transaction is that instead of choosing an item or a currency to be the cost, we'll use in-app purchase product IDs, which will be set up with your platform store. Now, there's definitely some extra steps here in order to get in-app purchasing working with Game Foundation. You'll need to work with the Unity IAP SDK. That can be installed from the services window. Once that's installed, you'll have to use the IAP catalog that's included in the IAP SDK to set up all your in-app purchases relative to the platform stores. And then, of course, you'll also have to set up the original in-app purchases on your platform stores. And that product ID is what we'll use throughout here. The same product ID that you set up on your platform store will be the Apple identifier and the Google product ID. So once that's set up, this works the same way as the virtual transactions in our prefabs that we'll show you in a little bit. You can basically, once you're done setting these up and get the Unity IAP SDK set up as well, it's really very simple to drag a store prefab in, choose a category that includes your in-app purchase transactions, and then make it look the way you want, and it's pretty much ready to go. Now that we have a bunch of transactions defined, let's go over to the store window and start putting all these transactions into a store. We don't have to create a store because there's one main store by default that you can't delete. We'll just add all those transactions that we created into this store. And then at runtime, your code can load up the store and display all these transactions for the player to purchase. Game Foundation comes with a number of prefabs that make it easy to set up things like stores and connect to data in Game Foundation. So let's take a currency item prefab, drag that into our scene in our store layout. Let's set up the gem currency, which we created earlier, and we added a gem icon to that currency. This prefab automatically grabs that icon from the currency definition. Then we can customize it by removing the background image. You can change the position of the text, change the font, reposition everything, stretch it out, do whatever you want, and the data is taken care of for you at runtime. Now we're ready to set up our store. We've created a little area to put our store in, and we're just going to grab the grid store prefab, drag it into our layout, and we'll adjust the rect transform so that it fits. And then we need to pick which category to pull products from. Could pull all, but we'll change it to just gem packs. That's enough to get it to work. When you hit play, it'll pull everything from the transactions we set up already. It'll automatically show the images we assigned, the custom names and everything. But that's not quite looking how we want. So we want to adjust the look of each individual store item. We'll make a duplicate of the store item prefab and start customizing that one. Let's get a new background in here. We want this green background. That's good. Now let's change how the display name looks. We can do anything we want to this font. We could even replace it with an image if we wanted to. You've got a lot of control over how you change these prefabs. So we'll change the color and size of the font, change the button image, then adjust the color of the button slightly, resize the button a little bit. We're going to crunch everything down a little bit, but you won't see that here yet. So let's take that new prefab that we've adjusted, make that the item prefab instead of the old one on our grid layout, and just replace it, and that's it. Now we hit play again, and it uses our new prefab, and you can see that here. So we've still got a little bit of layout adjustment to do, but we're going to do that on the grid layout group by adjusting sizes and spacings and things like that. So we're almost there here, and now we're looking good. Normally you'd get the whole in-app purchase process if you click on one of these, but for this demo, we're just sending it right to your wallet so you can see your gems increasing. And it's that easy. Now that we have our gem store set up, let's set up a store with virtual transactions to buy balls. It's the same process as with our gem store. We're going to drag a grid onto our scene. We'll adjust the rect transform to fit. Then we'll pick the ball category to show in this store. So we'll hit play. We should see, just like before, same default layout. We don't like those. We don't like how those items look, so we'll replace those with a new copy of the store item prefab. We'll make some similar adjustments that we did for the gem store. We'll change out the background to that same green background here. And then instead of adjusting how the name looks, we're getting rid of the name. We'll just go with images and prices. We'll adjust this price button here, and then that's good enough. Now, same as before, we'll replace the store item prefab with the new store item prefab that we just made. And we'll see that it's, a bit spread out, so we can adjust that grid view again. And you see that there's virtual transaction prices showing with the icons for the currencies in those virtual transactions. Now let's look at the store running in our game. So we'll click on the store button, and there it is, just like we set up. You can see the wallet filling with gems thanks to our in-app purchases. And then we can go to the balls category and spend gems on balls. And all of this took very little time to set up. Let's talk about a cloud backend for your game. Game Foundation integrates easily with Chili Connect. You can download the Chili Connect SDK for Unity from the Chili Connect website, then import that package into your project. That will take a couple seconds to import and then recompile. We're going to need another piece to this, and that's going to be the Chili Connect adapter for Game Foundation to connect the two. To get that, we're going to go to the package manager. Just like when we installed Game Foundation, we're going to search for Game Foundation again. And then once we find Game Foundation, we're not going to import a package. We're going to import the Chili Connect sample. That'll show up in your assets. Find that. Inside that is the Chili Connect adapter for Game Foundation. That's another package that you want to double click, import it. That'll take a couple seconds and compile, and then you'll have everything you need to integrate Game Foundation with Chili Connect. Now let's sync your Game Foundation data to Chili Connect. Your dashboard for Chili Connect is going to start out empty. So let's go to your project, and in the Game Foundation Chili Connect window, first you'll need to set up your game. You get the token and secret from your Chili Connect dashboard and paste them in here for the game that you want to connect. Then when you click Export Catalogs to Chili Connect, everything that you set up so far in Game Foundation will be uploaded to Chili Connect. Then when you go to the dashboard there, you'll see that all your inventory items and transactions that you set up in Game Foundation are set up the same way now in Chili Connect. Chili Connect is now going to be the authority for catalog data for our game, but we need to publish it first. But we can throw in a couple extra items on the Chili Connect side that will also show up in our game. Let's add a cat ball item, and then we'll make a transaction so you can spend some gems and get a cat ball. So we'll create a new virtual purchase and give it a name, give it an ID, make it cost 10 gems. And then for 10 gems, you get one cat ball. We're also going to have some custom data to associate with this so that we can have an icon in our store. We'll just paste in the JSON data that we prepared before, and that gives it a path to the icon for this product. Now that that's set up, we can click Publish, and now Chili Connect can publish this catalog data to your game. Now that our game's connected to Chili Connect, let's hit play, open up the store. We'll go look and see. There's the cat ball product we set up in Chili Connect. So Erika, what's next for Game Foundation?
Thanks, Rich. Game Foundation has a lot of great plans in the pipeline that we're excited to share with you. In the latest build, we're introducing a new type of catalog item called Game Parameter, which allows you to define static properties for global level concepts in your game. Game Foundation will introduce specific settings under this section over time to allow you to configure its behavior and make sure it works across different systems and services. But as a developer, you also have the flexibility to define your own game parameters. And these custom properties you define will have cloud catalog sync and A/B testing capabilities out of the box, just like the systems we saw earlier. Here's an example. Let's say you have a daily quest feature you just built and want to decide whether to turn this feature on in your live game. You can define a feature flag for it as a game parameter. This parameter can then be changed through a cloud catalog update sent to all game clients to allow you to decide when you want to enable or disable the quest. This parameter can also be turned into an A/B test, and soon we'll provide a seamless integration with the Delta DNA service so that you can learn more about the impact this feature has on your players' engagement in your game. Another improvement we've made in the latest build is the addition of two types of properties. Mutable properties, which are for attributes that change at runtime that you want to track per instance, and static properties, which are for things that don't need to change after they are initially defined, and thus don't need to introduce unnecessary overhead at runtime. As an example, let's say you defined a new weapon item called Short Sword in your game. Here, the static property could be things like the weight or durability of the item, which stay the same for all instances of this short sword. And the mutable properties could be things like damage boost or cooldown, which apply uniquely to any particular instance of the weapon, and which change at runtime during gameplay. Over time, Game Foundation may introduce built-in properties for each type of definition to provide a minimal contract on the necessary information required to describe that concept. For example, the initial allocation amount that we provide for inventory items. Another new feature we introduced in the latest build is a code generator to help provide a strongly typed C# reference for the concepts you defined in Game Foundation, without having to refer to them by their string reference. This is our very first step in enabling code generation as part of the Game Foundation workflow, and we will look into other potential areas in the future, such as generating the data bindings or cloud code that can match the Game Foundation catalog definitions. Besides these updates that we're releasing in the latest build, there are many other features we're working on for future releases. First, we plan to provide many more common game systems to extend the use cases that Game Foundation can help with. For example, systems and prefabs related to managing rewards that you can give to players, running special offers or promotions, and things like quests that you can quickly define and distribute to players to keep them engaged and enjoying your game. We'll also be providing more prefabs that cover many common use cases. We strive to design these in ways that are unopinionated but flexible, and useful enough that developers can each find something that you can fit into your project's needs, regardless of the type of game you're making. You've seen Store Prefab, our first offering in this regard, but we're doubling down on this direction, and a lot more high-quality prefabs will be coming in the near future. We'll also continue to improve the editor user experience and how it fits into your Unity workflow. This will include things like supporting addressables and polishing the editor UI to make it easier to manage large-scale projects with a lot of game content. When it comes to experimentation, we are actively working on providing support for A/B testing of different configurations of your game. This system will be flexible enough to allow you to define and test most aspects of your game economy resources and Game Foundation system configurations. We also want to provide you the ability to personalize your game experience based on player segmentations you define. We talked already about our current server-side data layer support, but we want to expand this even further to include things like a fully server authoritative mode, or to define places where you want to run certain code in the cloud instead of locally. We hope this will help developers save a lot of development effort and reduce complexity in these back-end areas. We're also working on supporting new Unity services, aiming to provide day one integration when they launch. Our goal is to provide a seamless full-stack development experience in Unity with Game Foundation. Stay tuned for more details on these in future announcements. With that, Rich, I, and the rest of the Game Foundation team want to thank you for tuning in. We're excited about the features in Game Foundation and can't wait to hear what you think. You can follow the link on the slide to get to our landing page. The preview package is available in Unity Package Manager, so you can download and test drive these features now. And please, reach out to us on the forum to let us know your feedback, questions, or suggestions. Thank you.